Now for some even harder composite inverse trig graphs. Now in these ones, you've got one bit that's not an inverse and one bit that is, and you've got, instead of cos and sine, we've got a mixture here. So the key thing to do here, I think, is to work on something you already know and see if you can transform this into something that you know that's got a couple of other transformations in it. Now, before we even start, let's just revise something really quickly. In any right-angled triangle, we've got 90 degrees here. So this one and this one have to add to 90, right? So if we call this one, say, x, then this one is 90 degrees minus x. Or if we're working in radians, then we call it pi on 2 minus x. Okay, now if we're finding the sine of this angle, it's going to be opposite over hypotenuse. And that's going to be the exact same as the cos of this angle because that's adjacent over hypotenuse and it's the same two sides. Now I've learnt this already in our first advanced trig unit. This is a basic identity. So we know already that the sine of one angle equals the cos of 90 degrees minus that same angle. Okay, so a way to use this, if I know that the sine of 10 degrees is something, it will be the same as the cos of 80. Okay, so we can always change sine into cos. If we don't want to use it, we can use the other one. But to make up for it, we have to do 90 minus whatever we had. And we can do it either way around. So here, I'm thinking I want to change one of these. And it makes sense to change this one. Instead of sine of x, how about we call this cos of, and we can use 90 degrees, but let's go with radians since we're good with those now, pi on 2 minus x. Okay, now we've got that. All right, now how's this going to help us? Well, haven't we already worked out what the graph of this looks like? Okay, this is one that we just did. And if we hadn't just done it, we could do this one first. Now we've considered this and we came up with a graph that had that sawtooth shape that went up and down like this. So a quick sketch of it again to remind ourselves. Now it went up for pi, down for pi, up for pi, down for pi. So now we've got a pretty good sketch there that's going to help us because this sketch here is actually quite a lot like this one. It's just got two transformations. Now you might spot it better if I said, let's just graph this one next. Let's graph this and see how that's going to help us. Now compare these two. What's the difference? This one's got x, this one's got negative x. Okay, what happens when you change the x's into negative x's? Doesn't that make it a reflection, a horizontal reflection around the y-axis? Yep. What's that going to do to this graph? Absolutely nothing. Great. So in other words, we've already just graphed that one. Perfect. Okay, so now that we've graphed that one here, we can rewrite this one around this way, just seeing how we've looked at it. Now we've got negative x, but we've added pi on 2 because that is exactly the same as this, right? Now this looks like we've somehow slid this thing to the left or right, doesn't it? Now here's the trick. Remember that when we actually make a translation to the side, we change x into x plus or minus something. And if we've done x plus something, we move it to the left. And if we've done x minus something, we move it to the right. So that's a rule we've already learned. But that's changing x into x or plus or minus something. It's not changing negative x. Okay, so what we need to do here, and this is quite tricky, is we need to actually factorize this thing a little bit further and say this part here is the same as negative x minus pi on 2. Now, I want you to just have a quick look at that and check that that actually expands out to give me the same thing as that. It does, doesn't it? Now, you might be wondering why I've bothered to rewrite this way. But by changing, if I can compare this one with this one, yes, this one's negative x, and yes, this one is negative x too. But this one actually shows me that I've changed the x here, just the x, not the minus x, just the x part, into x minus something. And that's telling me that I need to move pi on 2 units to the right. Okay, so that's my instruction. Start with this graph, and then I need to move pi on 2 units to the right. And pi on 2 is here. So in other words, I need to move this point over a little bit. So let's grab another color and draw our new graph in blue. This point will go to here. This one will come over half a point there. This one will come over just half a pi. And so we'll get this, and this one will come over. And so we end up with this blue line here. This is coming over half. Whoops. And we've got our new graph. So this blue one is now this graph here. Now, a little bit of a process there and a fiddly little thing to do in the end. But really, the key point was, first I changed sine into cos and made up for it. Then I noticed that this looks like some transformations. So to identify them, I started with the reflection, which didn't really do anything. And then I decided to just rearrange that so that I could see the reflection, and I could also see the translation where I'm changing x into x plus or minus something, not changing negative x, because that is not the rule that we've learnt with sliding things to the left and to the right. Now, with these kinds of graphs, you don't want to go memorizing what they all look like, because there's so many different possibilities of things that you could get. You're best off thinking it through freshly each time, come up with a graph that you know, and transform it as required.